Okay, so let's continue with how to work with graphs, basic things about graphs in Scipy. Okay, so Scipy gives us this module called sparse CS graph. Okay, it's usually called CS graph module, but you call it as scipy.sparse.cs graph. Okay, so how do you use it? Well, usually NumPy is already there. You always need NumPy. Then you can call it as from scipy.sparse.cs graph, and then whatever you need. Okay. So for example, there is something called a CSR matrix that you will need from Scipy sparse. Okay, we'll get to that in a moment. Okay. Right. So what does this mean? So with this module, we can always feed in the adjacency matrix of a graph, and Python will understand what the graph is. Okay. Everybody knows what the adjacency matrix is, right? For example, this is a very basic example. This is the vertex set. And if there are n vertices, n cross n matrix, okay, if there is an edge between two vertices, then the corresponding entry in that matrix is 1, otherwise the corresponding entry is 0, right? But here you can do more. You can consider weighted graphs, okay? So the edges can have weights, right? So an undirected graph without weights is supposed to be considered as having weight 1. If there is no weight, it means the edge has weight 1. But instead of 1, you can give other weights also, other non-zero weights also. For example, here you have an edge with weight 2 and an edge with weight 1. Okay. So in this case, the adjacency matrix, the weights, the elements will not be zeros and ones, they could be other weights also. Other weights also. Okay. That is the only difference. So how do you feed this into Scipy, or rather into Python using Scipy? Okay. So the adjacency matrix of this graph, for example, looks like this, right? So it's a 3 by 3 matrix, which is fed as a sequence of 3 arrays, one for each row. The rows are indexed by vertices, the columns are also indexed by vertices, and then, for example, the edge joining A and C has weight 2, right? Similarly, edge joining C and A, it's a symmetric matrix, so the same value comes back. Okay, so what we are really interested in is in this very basic thing called connected components. This is the first thing we will look at. Okay, if you are given a graph, is it connected or not? Or how many connected components are there? How do you find that out? Okay, for that, the method that you use is connected components. And this you will find in this module, scipy.sparse.cs graph. So from here, you have to import the method connected components. Okay, but how you enter the adjacency matrix as an array, but how will Python understand that it is supposed to be a graph? Right? It could be just any array. Why should it be a graph? In order to make Python understand that it's a graph, that's where you use this thing called CSR matrix. Okay. So you import this again from scipy.sparse. And how do you enter the graph? You first enter the array of the adjacency matrix, then you convert it using the method CSR. Okay. This is your original array, the adjacency matrix. Form a new array as CSR matrix of ARR. What this does is now Python will understand that this is the adjacency matrix of a graph. Okay, so this is the adjacency matrix of your graph. And now you simply look at connected components of this graph. Print connected components, new ARR, it will tell you how many components are there. Okay, so let's do this on some other example where you have more than one component. So let's consider the same example plus 2 more vertices. Okay, so let's do it here. Yeah, let's do it. Okay, so import numpy is np import. Okay, from scipy.sparse.cs graph import connected components. Okay, then from scipy.sparse import CSR matrix. Okay, this much we have. Right? Now what are we doing? We are entering an array. So ARR equal to np.array, right? So how many vertices we want? We want 5 vertices. Okay, so 1, 2, 3, 4, 5. Okay, 5 vertices. So 1 row for every vertex. I'm entering it this way in one single line. Okay, I'll adjust it later on. Or okay, so yeah, I forgot to put the outer bracket. Yeah, now we are fine. Okay. So 1, 2, 3, 4, 5. 5 vertices. The first part is the same thing, the same graph. So let's do this. ABC 0, 1, 2, 1, 0, 0, 2, 0, 0. Okay, so just pay attention. 0, 1, 2, 1, 0, 0, 2, 0, 0. Now you know that this graph is supposed to be connected, right? Okay, this part. So the other two vertices, the other two rows have no connection with these vertices. There are no edges. So for the other two vertices, corresponding to these first 3 vertices, there are no edges. So the weights are 0. And it's a symmetric matrix, so you'll have to do it on the other side also. Okay, so there are 5 columns, 5 rows. But the first 3 by 3 part is a graph by itself. And there are no edges between the first 3 by 3 part and the next 2 by 2 part. So you have this part to be 0, this part to be 0, as well as this part to be 0. Now the remaining outer extra 2 edges, 2 vertices, by themselves, what will they have? So let's put some weights. Let's put 2, 1, has to be symmetric, 1, 2. So do you see? This has a 3 by 3 block and a 2 by 2 block. There are no edges between these blocks. So this is supposed to be a graph which is having 2 connected components. One connected component will look exactly like this. The other connected component will look slightly different. Okay. Let me just say 0. That's not happens. Now new r is equal to. Okay. Now Python has to understand that this is actually the adjacency matrix of a graph. So CSR matrix, then print. Right? 2. See, forget about this part. This is not important to us. What is important is the number 2. It shows that it has 2 connected components. Okay. Now a graph is connected if and only if it has 1 connected component. So if you see 1, it means that graph is connected. All right. Yeah, good. So that was about graphs. Another thing that we have actually done in the previous course is finding shortest path. Remember, finding shortest path between 2 pairs of vertices, a pair of vertices. Right? So how will you find the shortest path? We have done Dijkstra's algorithm. And here you can just use a command and implement Dijkstra's algorithm. It will do it for you. How do you do it? Again, from scipy.sparse.csgraph. Now you use Dijkstra, D-I-J-K-S-T-R-A. That's the spelling. Okay, and nothing different. Absolutely nothing different. Array, you adjacency matrix, enter it as it is, convert it to CSR matrix. Then you don't even have to give the other parameters. Other parameters are unnecessary for us. You can simply say print Dijkstra new n. Print Dijkstra new n. That's it. Okay. So yeah, so this you try it on your own because there is not really much of a difference. It's only the last command that you have to change. Print the extra unit. So try it for this itself. Okay, so let's try. What do we get? I get some, oh, sorry, I did not change this, right? Yeah. Okay, so what does this give us? Gives us the full array. So we have 5 vertices. Okay, so for example, look at the second row and third column. This number, what does it say? The shortest path length from the second vertex to the third vertex is the number 3. That is what it says. Okay. Similarly, why is it infinity? Because this vertex, it's the fourth column. Fourth vertex is in the second component. There are 2 connected components to this graph, right? So between connected components, there is no edge, and therefore the distance is default. It's not number now, it is just default command, which is mentioned to be infinity, which means these two are not in the same connected component. Therefore, there is no path between them. That is the mean. Okay. So you did not even write a code for Dijkstra. It just did Dijkstra's algorithm for you. Not even for a single pair of vertices, but for every possible pair of vertices. You can read off the shortest path length between any 2 pair of vertices by looking at this matrix. Okay. Another example, the third vertex to the first vertex. What is the shortest path length? So look at the third row and the first column, and the number is 2. So the shortest path length is 2. Okay. So that's how Dijkstra is done. Very, very easy, very, very simple. Okay. And this is why this is so useful. So in the previous course, you saw how what are the actual algorithms behind these things, and you understood that it's not easy to write these algorithms, but Python has it inbuilt inside itself, and you can just apply these algorithms by using a single command. Very, very easy. Okay, so that is the algorithm for finding shortest path. So that is it about graphs actually, and there's one smaller part about this that I would like to do. That's about significance tests. So I'll do that in the next part of this video. Okay, so I'll stop here.